will fly across the southwest US today to learn about alluvial fans. After watching this video, you should know what they are, where they occur, how they are formed, and why they are important. Let's start in Death Valley, California, a place notable for its exceptional geology. Alluvial fans are fan-shaped depositional landforms typically found along mountain fronts where a stream enters a basin. Do you see these features in the satellite image? Alluvial fans look like half circles or triangles in map view. Let's move west to the Owens Valley to look more closely at these landforms. At this location, how many fans do you see? 3 neighboring fans are coalescing to form an apron of sediment along the mountain front called a bajada. We now know what these landforms look like from above, so let's get a view from the field. When a stream exits a steep mountain canyon and enters a relatively flat basin, it flows with less energy and loses competence, or the ability to transport sediment, and deposits its sediment load, forming an alluvial fan. The water-transported sediment, or alluvium, is usually sand to gravel in size. Once the stream enters the basin, it is no longer confined by valley walls and has room to spread out. Additionally, the decrease in gradient leads to slower water velocity, and alluvium is deposited on the fan surface. Numerous distributary channels are commonly observed on fans. The fan's shape is produced from stream flow essentially migrating back and forth between distributary channels, which originate at a fixed point at the mountain front called the apex. Can you tell where sediment has recently been deposited on this fan? Sediment has most recently been deposited on the left side of the fan. You can see that this surface exhibits a lighter color, relatively sparse vegetation, shallow gravelly channels, and surrounding fine-grained sediments. Compare this to the inactive part of the fan to the right. This part of the fan is darker in color, has more well-established vegetation, and older channel features that are hard to distinguish. Alluvial fans have distinctive geometries that help geologists identify them in the field and in the rock record. Looking across the fan, the profile shows a concave down geometry. The downslope, or long profile, commonly exhibits a constant slope or is slightly concave up. Moving further down the fan slope, we are now looking toward the center of the basin. The Sierra Nevada mountain range borders this basin to the west. The alluvial fans transition to alluvial plains toward the basin center. Notice that the channels become much smaller, moving toward the toe or the terminus of the fan. With this in mind, what do you think happens to grain size as you move from the apex to the toe of a fan? A. Grain size increases. B. Grain size decreases. Or C. Grain size stays constant. The correct answer is B. The velocity of water that is transporting sediment decreases moving downslope, causing larger particles to be deposited near the apex and smaller particles to be carried further toward the basin's center. Let's fly over to the San Luis Basin of southern Colorado. Here you can see multiple fans that flank the Sangre de Cristo Mountains. Compared to the Owens Valley fans, these show more vegetative cover and have been modified by humans, as road construction, logging, and quarrying are common in this area. Let's get another field view of fan geometry from the gravel quarry. From this view, you can see the canyon from which this fan originates and the shrubby vegetation that mostly occupies channels. Looking at the cross fan profile, do you see a concave up or concave down surface? The cross fan profile is concave down. Before we take a look at the long profile, take a minute to observe this mini alluvial fan that is forming in the quarry. You can easily observe the fan shape and the small confined gully from which it emerges. Stream flow is essentially funneled down this steep gully and loses power once it reaches the mouth, causing alluvium to be deposited. It is important to note that fans can occur at all scales and in many different environments, including the seafloor and on the surface of Mars. And now, finally moving toward the long profile, you can see a nice slight concave up surface. So, we just spent 5 minutes flying over alluvial fans. Why? Why are they so important? As you just saw, they can be mined for gravels. What are some other reasons that these features are so important, both in modern environments and in the geologic record? Modern and ancient alluvial fan deposits can be excellent sources of groundwater and potential hydrocarbon reservoirs because fluids can accumulate and be stored between their sand to boulder-sized particles. Alluvial fans can also give geologists clues about mountain uplift and erosion histories.